2/25. We only have a few more Fridays left. Kind of exciting, but kind of sad at the same time. I'm going to miss my students. Today we're going to do a quick review over the notes we had from yesterday and add a few extra notes. So if you were not here yesterday, you need to get a note packet, go into yesterday's PowerPoint that is already loaded in Google Classroom, and complete your notes. Those of you that were here yesterday, you're going to need to pick up your note packet here in a few minutes, and then you are going to use the backside of the note packet to finish the notes that we need to finish. After we finish the notes, we're going to do a couple of practice so that you are able to identify different types of mutations, because these are on your test, your semester exam. After we finish the practice, then you will have a worksheet to complete. If this worksheet is not completed by the end of the day, it is homework and it is due on Monday, 5/5, Cinco de Mayo. Okay, no cell phones, period. I don't want to see them. Okay, if they're out on your desk, if they're laying on your desk, it's fine. I don't want to see them in your hands. I don't want to see you using them. The only way you can use them is with permission. And that means you go, Miss Clemmer, do you mind if I take a picture of the notes and blow it up and use it? And then I better see you only doing that. Okay. If your phone is being used without permission, it is going to be put in the wooden box, the wooden phone box, every day for the remainder of the year. I'm done. I'm done with cell phones. I have a lot of people not passing, and it's mainly because you're not paying attention. Okay? If you're sitting there talking to somebody, I'm going to start moving you. You've got to pay attention. This is the end of the year. We don't have time to sit and chit-chat and talk and play on our phone. You guys only have basically 2 weeks left of learning and a week of finals. Okay? If I do take up your phone, you'll get it back the last 5 minutes of class, your time. You might as well get used to having your phone put up and put away, because remember, next year you cannot use it. You cannot have it. I'm not sure how the district's going to handle the new law that starts in August, but it's going to be a state law. Okay? If it is not a private school, they have to figure out how to keep cell phones out of the classroom. Anyways, we're not going to get into that. Moving on. Okay, mutations. There are two types of mutations that we went over yesterday. We have gene mutations, which are genetic. Okay, that means they're genetic, and chromosomal mutations, which are heredity. Okay. A gene mutation is any change in the nucleotide sequence in a particular gene due to errors of DNA replication and mutagens. It affects only a particular gene. The consequence can be small or large, such as sickle cell anemia. Gene mutation types. We have a point mutation, aka substitution. A mutation where one nucleotide is put in place of the correct nucleotide, usually caught and fixed by DNA polymerase. If not, the substitution may permanently change an organism's DNA. Remember, this is like asking Miss Clemmer to substitute in for a basketball player, and Miss Clemmer does not play basketball. I would make the team lose. I would definitely be the mutant of the team and make the team lose. Here you see an example of a point mutation. Okay, the T is changed to a C. It is substituted. Frame shift mutation. This involves the insertion or deletion. So either one is being put in or one is taken out of the nucleotide in a DNA sequence. This shift moves the entire sequence by one or more nucleotides. So everything shifts to let one in, or everything shifts to let one out. An example of this is cystic fibrosis. Remember, a frame shift is like standing in line waiting for your favorite ride, and somebody else jumps in line in front of you, or they decide they don't want to ride it and they get out. You shift forward or shift back. Okay. Here we have deletion and insertion. They change the reading frame, which results in different codons that might code for a different amino acid, which codes for a different protein, which codes for a different trait. So here you have the first sentence, the dog sat. If we take the H out, now we have Ted Oggs at. Here is just a quick animation about gene mutation. Oops, sorry. Go back. Okay, well, it doesn't want to do. Okay, so never mind. Okay, missense mutation. A missense mutation is a change that results in a different amino acid being coded. Okay, so you have AAG, codes for lysine. You have CAG, so it's a missense. It doesn't make any sense that it's coding for a different mutation, or excuse me, a different amino acid. Nonsense mutation, a substitution that codes for a premature stop codon. Okay, so we have UAC, which should code for tyrosine, and instead we have UAA, which throws up a stop sign, and so we have to stop early. Okay, unexpected stop sign. This is like road construction, and all of a sudden the guy flips the sign around that says stop. You were not expecting that stop. Okay, but remember, if there's a stop, you do not go any further. You stop. This is a nonsense mutation. A nonsense mutation, it substitutes, the substitution codes for a premature stop. Okay, remember some codons code for the same amino acid. Okay, let's suppose an A is substituted for the G. This is what they consider also a silent mutation, because usually you don't know what happens. A substitution that could have no effect, so it's not going to do anything, usually. Okay, 90% of the time. Remember that this type of mutation may or may not affect an organism. Like I said, usually there's no effect, 90% of the time. Here you have AAG. It is coding for lysine. AAA, also coding for lysine. It's silent. Yes, it's a mutation because the G and the A have been switched, but it's still coding for the same amino acid. Chromosomal mutations. Chromosomal mutations are a change in the structure or number of chromosomes caused due to duplication, deletion, or translocation. It affects many genes. The consequence is large, and it can be lethal. Example of this is Down syndrome. Here we have a chromosomal mutation. It is a change in the number of structure of chromosomes. There are 4 types. We just said that. Chromosomal mutations include deletion, duplication, inversion, and translocation. Deletion involves the loss of all or part of a chromosome. A, B, C, D, E, F. Deletion, A, B, C. The B is deleted. We now have A, C, D, E, F. Duplication produces an extra copy of all or part of a chromosome. Okay, so duplication, A, B, C, D, E, F. A, B, B, C, D, E, F. We duplicated the B. Inversion reverses the direction of parts of a chromosome. Basically, it flips. Piece breaks off, flips around, reattaches to the same chromosome. We go from A, B, C, D, E, F to A, C, B, D, E, F. Translocation occurs when part of one chromosome breaks off and attaches to another. So here is a GH that broke off of one chromosome, and it's now attached down here where it used to go ABC. We now have ABGHC. Okay, now we are going to do some practice. You're going to need a sheet of paper, or you can use, if you still have room on the bottom of your page, you can do this. We're going to practice it together, okay? And we're going to figure out our mutation and what type of mutation it is. Here is our second one. Okay, so we already did the first one. We're doing another one now. Yes, they look the same, but they're not the same.